Hello everyone, good afternoon, welcome to my channel. In this lecture I am going to explain another important application of differential equation, that is Newton's law of cooling. So before jumping to the numerical, let us understand what is the concept of Newton's law of cooling. So what I'll do, I'll explain in detail what is the basic concept of Newton's law of cooling, then after we'll go to numerical. Okay, so without further delay we'll start the lecture. My name is SR Pusti and you are watching my lovely channel Love You Science. So let us start. So Newton's law of cooling क्या है? As per the definition, the temperature of a body changes at the rate which is proportional to the difference in temperature between the surrounding and body. So this is body or system, and this side is surrounding. Let body temperature is theta and surrounding temperature is theta naught. Okay. As per the definition, the rate at which temperature changes, that is d theta upon dt. That is directly proportional to the change in temperature between body and surrounding. मतलब directly proportional to theta minus theta naught. Understood? Again I repeat, body temperature is theta, surrounding temperature is theta naught. And as per the Newton's law of cooling, the rate at which temperature decreases or temperature changes, that is d theta by dt, is directly proportional to temperature difference between body and surrounding. Matlab d theta by dt is proportional to theta minus theta naught. So implies I can write d theta by dt is equal to some constant k into theta minus theta naught. And another point to remember, you have to put a negative symbol here. Negative symbol is there because cooling. Understood? So ये expression you have to remember. Every time we will implement this expression while solving numerical. ठीक है? So इसको पहले note कर दो. Let us solve a numerical. The rate of temperature of a body is proportional to difference between the temperature of body and surrounding air. If temperature of surrounding air is 25 degrees Celsius and the body cools from 100 degrees Celsius to 75 degrees Celsius in 1 minute, find the temperature of body at the end of 3 minutes. So from the question itself, it is given surrounding temperature matlab theta naught, which is given 25 degrees Celsius, and the body cools from 100 degrees Celsius to 75 degrees Celsius in 1 minute. So how to solve this numericals? I am going to give a trick. Trick क्या है? देखो, you make a table in one column you mention time, in other column you mention temperature. So you have to take three different level of temperature, and the temperature you have to take from higher value to lower value. So apart from this 25 degrees Celsius, there are how many temperature? One is 100 degrees Celsius, next to 100 degrees Celsius is 75 degrees Celsius, and last one is theta. You have to find out theta, and corresponding time you have to mention. So while taking the corresponding time, you start from the mean value to max value. So there are how many time? Two time. One is 3 minutes, second is 1 minute. So maximum value is 3. You will start from the bottom line. So 3 minutes. Next time is 1 minute, and last one, if nothing is there, matlab time is 0 minute. Or else from the question you can make the table like from 0 to 1 minute body cools from 100 degrees Celsius to 75 degrees Celsius. After 3 minutes, what is the temperature? Okay. So as per the Newton law of cooling, what is the standard formula? D theta by dt equal to minus of k theta minus theta naught. Understood? So here I can write d theta by theta minus theta naught equal to minus of k dt. So d theta by theta naught कितना है? Theta naught is 25 degrees Celsius equal to minus k dt. ये हो गया आपका primary equation. So now the point is you have to integrate this function 2 times. While integrating this function 2 times, remember 2 times. For the first time your limit is from 100 degrees Celsius to 75 degrees Celsius. Corresponding time is from 0 to 1. For the second time integration के लिए क्या करना पड़ेगा? 100 degrees Celsius to theta degrees Celsius and 0 to 3 minutes. मतलब for the first time integration, lower limit is 100, upper limit is 75, time is 0 to 1. Similarly, for second time integration, lower limit is 100 degrees Celsius, upper limit is theta, and for time, lower limit is theta, upper limit is 3. Clear? So if I integrate first time, if I integrate this function, so it will be ln theta minus 25. Understood? And what is the limit? Limit is from 75. Sorry, lower limit is 100, upper limit is 75. Is it clear? Okay. And it is what minus k is constant dt integration at t का लिमिट क्या है 0 to 1. Okay, so here it will be theta में प्लेस करो 75 minus 25 minus of ln 100 minus of 25 equal to minus k 1 minus 0 is 1, मतलब it is minus k. ठीक है, so it is ln 50 minus of ln 75 equal to k. So from this, by using calculator you can get this value of ln 50 and ln 75. If you subtract you can get this answer. Already I have I think mentioned ये ln 50 का वैल्यू क्या है 3.9120 3.9120 माइनस ln 75 का वैल्यू है 4.3174 equal to minus of k. Understood? So if it is minus of k, k will be coming 0.4054. Okay, so k is coming 0.4054. So now if we'll go for the second time integration, if we'll go for second time integration, okay, formula क्या है d theta by theta minus theta naught मतलब 25 डिग्री सेल्सियस इक्वल टू क्या है माइनस ऑफ kt k into dt. If I'll integrate this function, it is ln theta minus 25, it is minus of k. Okay, so it is minus of k, integration of dt is t, and what is the limit here? And the limit is from lower limit is 100, upper limit is theta, and for time lower limit is 0, upper limit is 3. It is clear? So मतलब it is ln theta minus 25, ठीक है, minus ln 100 minus 25, ठीक है, will be equal to minus k 3 minus 0 is 3, मतलब minus 3k. Okay, so here I am writing, so now ln theta minus 25 minus ln 100 minus 25 is 75 equal to minus k into 3. So ln theta minus 25 minus ln 75 का वैल्यू कितना है 4.3175 इक्वल टू माइनस k का वैल्यू कितना है 0.4054 into 3. ठीक है, so from this expression you can get ln theta minus 25 will be equal to, इसको सॉल्व करो, ln theta minus 25 will be coming 3.1012, इसमें ऐड करो, I think it is coming 3, हाँ ठीक है 3.1012. Okay, so ln theta minus 25 is coming 3.1012, मतलब theta minus 25 will be coming e to the power 3.1012. So e to the power 3.1012, use calculator. Let me get the answer from calculator. It is coming 22.224. So implies theta will be 22.224 plus 25. So your final answer is 25 plus 22, I think 47. So it is coming 47.22. 47.22 ये हो गया आपका फाइनल आंसर. आई होप इट इज क्लियर, इसको नोट करो. नेक्स्ट क्वेश्चन देखो, a metal ball is heated to a temperature of 100 degrees Celsius at t is equal to 0 and it is placed in water which maintains at 40 degrees Celsius. If the temperature of ball is reduced to 60 degrees Celsius in 4 minutes, find the temperature at which the ball is at 50 degrees Celsius. मतलब the surrounding temperature जो कि least temperature is given theta naught which is given 40 degrees Celsius. What I've told in my previous slide, you make a table, in one column you mention time, in other column you mention temperature. For the temperature, how many temperature except 40 degrees Celsius? 3 temperature, 100, 60 and 50. So mention in order wise like higher to lower value. First is 100 degrees Celsius, next is 60 degrees Celsius and third one is 50 degrees Celsius. ठीक है, and for the time you mention from lower value to higher value. So as it is said, it will start from 0. Matlab, the first time is 0, and next is 4 minute, and third time you have to find out. Okay, procedure same hai. First you have to write the equation as per the Newton's law of cooling. D theta by dt equal to minus k theta minus theta naught. Okay, so d theta by theta minus theta naught equal to minus k dt. Then d theta by theta minus theta naught is 40 degree equal to minus k dt. Now the point is you have to integrate this function 2 times. For the first time integration, you will start from 100 degree Celsius to 60 degree. Matlab lower limit is 100, upper limit is 60. For time, lower limit is 0, upper limit is 4. And for the second time integration, while getting the answer like constant, second time integration ke liye, you start from 100 to 50 and 0 to t. Matlab lower limit 100, upper limit is 50. Here lower limit is 0, upper limit is t. So let us integrate. If I integrate this function, so your answer is ln theta minus 40. And what is the limit? Limit is from 100 degrees Celsius to 60 degrees Celsius. Now if you integrate this function minus k, to constant है minus k, dt का integration क्या t, and what is the limit? Limit is from 0 to 4. Understood? So here ln 60 minus 40 minus of ln 100 minus of 40. ठीक है, इक्वल टू माइनस के इंटू 4. 4 minus 0 is 4. मतलब it is ln 20 minus ln 60 equal to minus k into 4. Now you can get the answer by using calculator. ln 20 का वैल्यू कितना है? Okay, let me use the calculator. ln 20 is coming 2.9957. मतलब 2.9957 minus ln 60 is 4.0943. 4.0943. You can cross check by using calculator. Equal to minus k into 4. So from this you can get the value of k. Already have solved that question. K is coming 1.0986. K is coming 0.2746. 0.2746. It is k. ठीक है. And for the second time integration के लिए क्या करना पड़ेगा? Same thing. Okay, here I am writing. पहले इसको नोट करो. नोट कर लिया? ठीक है. तो second time integration here I am writing. Same expression. Okay. तो इसमें क्या है देखो? If I integrate this function, so it is coming ln theta minus 40. ठीक है. So limit क्या है? Limit is from कितना था? Limit is from that 100 to 50. ठीक है. And here it is minus k. T का limit क्या था? T is from I think 0 to T is 0 to t, because you have to find out t. Okay. So here ln 50 minus 40 minus ln 100 minus 40 equal to minus k into t. Okay. So it is ln 10 minus of ln 60 equal to minus k into t. So now ln t is, calculator use करो, ln t is ln 10 is 2.3025. 2.3025 minus ln 60 is already we got 4.0943 equal to minus k कितना है? 0.2746 into t. Now you can solve this equation and you can get this answer. So मैं answer लिख रहा हूँ. Time it is coming 6.5 minute. 6.5 minute. ठीक है. So that is all about Newton's law of cooling. So with this I am ending this lecture. Hope you guys understand what I have explained today. Thank you so much for watching my video. If you like my video, please do subscribe my channel for further notification. So once again, thank you so much. All the best for your exam. Thank you.